section 12.2 is on measures of central tendency. And what we mean by that is if we were to plot all of our data pieces and look at the shape, which we love to do in statistics a lot, these types of numbers tend to land around the center. So they're not being super creative here when they say they have central tendency, because they tend to land in the center part of your graph, of your data. These are going to be items like mean, median, mode, midrange. Also in this video, section 12.3, which is measures of dispersion, and again, they're not being super creative here with the name. These are the numbers that if you're going to analyze all of your data points, they talk about how far those numbers disperse, hence the dispersion, how far they disperse around the center. So numbers like range and standard deviation tell us the spread. So measures of dispersion relates to the spread, how spread out your data are. Looking at example 1, it says use the following group of data, and they're all decimals. For this first example, I got A through F with the same numbers. You have a choice, honestly. A lot of this stuff can be done right in the graphing calculator, or you can do it longhand. I would recommend at the very least that you do standard deviation on the calculator, just because it's so time consuming to do it longhand. Starting with part A, it says find the mean, round to the nearest hundredth. So to find the mean just means we're going to add up all of the numbers we see, so just put a plus symbol there, and we're going to divide by the total number of data pieces that we are adding. So I put plus symbol divided by total number. So let's start by adding all the decimals we see. And I'm going to put parentheses around the numerator just because if you do want to type this whole thing in as one step into the calculator, then you are going to need to type in parentheses around the top. So we got 1.6 first, plus 3.8 is next, plus 5.0 or 5 is next. These three, then 2.7, then 4.2, then we have another 4.2 added every time you see it for mean. 3.2 is next, 4.7 is next, 3.6 is next. I'm already running out of room, so I'm going to have to continue down here. Plus, we got 2.5 is next, plus another 2.5. Close the parentheses. Divide by, we said the total number of data pieces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total data pieces in this example. Again, if you're doing this all together in the graphing calculator, you absolutely need those parentheses around the numerator. Even though view an example is not going to show you those parentheses, you need them in the calculator because that's your way of telling the calculator that that whole thing is in the numerator there. What I would recommend is maybe do it in 2 steps just to be safe. That way you don't have to put in the parentheses. So I'm going to add it up. You can probably hear my button clicking on the calculator right now. 1.6 plus 3.8 plus 5 plus 2.7. I encourage you to try this at home just to make sure you know where all the buttons are located at come test time. And when I add the numerator, I'm getting 38. So this is 38. Now we can divide by 11. And it says round to the nearest hundredth. I'm getting 3.45 with the 4-5 repeating, but they do want us to round, so I'm going to write the approximately wave here. The hundredth spot is 2 digits. Because the third digit is a 4, that means I'm going to round down, keep it the same as 3.45 approximately. So 3.45, final answer to part A. I'm going to go ahead and move that answer up so that I have room for part B. So you should be getting 3.45. Part B, median means middle. It even kind of looks like the word middle. They both begin with the letter M. They both have 6 letters, a D in their middle. But there is an important step if you're doing this longhand that's easy to forget. So 2 steps. Step 1 is you got to rewrite your numbers from smallest to greatest. Rearrange them in order at least. So think median means middle. In black here, I'm going to write step 1. So let's go ahead and rearrange this from smallest to biggest. So as I look through our data pieces, it looks like 1.6 is the smallest. I better slash these as I go, just to make sure I get them all. Comma, then I have 2.5, so 2.5, comma, 2.5. I see a 2.7. I don't see any others in the 2 range. So then up next is 3.6. Oh, sorry, 3.2 rather. I almost missed the 3.2. 3.2, then 3.6. It's always good to have something erasable in this section. Then 3.8. Then I got 4.2. So list them both. If it repeats, list all of them. Even the repeating numbers. 4.7. Put it on the next line since I've run out of room again. And then 5.0 or 5. I just keep writing 5.0 as. So there's step 1. Step 2, I'm going to do in red. Once they're in order, from smallest to greatest, now cross out 1 from each side and see what literally lands in the middle. Here we go. So 1 from the smallest and the biggest side. I'm slashing. And our winner is 3.6. So the median final answer is 3.6. Now, if there was a tie between 2 data items landing in the middle, what you would do as a tiebreaker is you would calculate the mean of those 2 numbers, and that would be your median final answer. We're going to see an example of that on the next slide. Up next, though, it's asking for mode, and whenever you see the word mode, it means the most common or the most frequent. So in other words, whatever number repeats the most number of times, whatever data piece repeats the most number of times. If nothing repeats, there's no mode whatsoever. You could have a tie. You could have some numbers repeating the same number of times. So you could have a tie and have several modes also. In this case, I am seeing a tie. I'm seeing 2 4.2s and 2 2.5s. So this is what we call bimodal, meaning 2 modes, 2.5, comma, and 4.2. Both occur twice, so they're both the winners of the mode. Up next is midrange, which is totally different than just range, as we'll see. The formula for midrange, which you might want to jot down in your notes, is you're going to look up the smallest number. Write hashtag again to abbreviate number, so smallest number. You're going to add it to the largest number. And then you're going to divide by 2. So smallest plus largest, divide by 2. Our smallest number, or smallest data piece, was 1.6, plus our largest data piece was 5.0, or 5. Divide by 2. Again, if you type it all as one line in the calculator, you absolutely need to hit those parenthesis buttons around the numerator, even though view an example isn't going to show you that. You want to make sure you're telling the calculator that all of that is in the numerator. I like to just play it safe, and I like to do it in 2 steps. So I'm going to do the 1.6 plus the 5 for 6.6. Then I'll divide that by 2, and I see that 3.3 is my mid-range. Final answer for mid-range, 3.3. I'm going to go ahead and move that answer up since I don't have a lot of room to write here. I'm going to try to leave the formula there. So 3. Regular range, which is what you more likely see on a standardized test, does not involve adding or division at all. That's why I say it's totally different. Regular range is just simply subtraction, because now you're talking about how spread out your data is. So you're going to take the largest number and just simply subtract from it the smallest number to get the range. Our largest number was 5.0 or 5, minus our smallest was 1.6. 5 minus 1.6 gives you a final answer of 3.4 for the range. Finally, the standard deviation. It says find the standard deviation, round to the nearest hundredth. You're more than welcome on the homework to click on view an example, and it's going to show you the more time-consuming way, which is writing everything out on paper. I'm going to try to save time, and I'm going to make my graphing calculator do the work and give me the standard deviation. If you choose to use this way, what's nice is the calculator also gives you the median and the mean, which we found earlier in this question, and it also gives you something called the quartiles that we're going to discuss later in this video. Okay, so we're going to talk about how we can use the stat button on your graphing calculator to find standard deviation and eventually quartiles. The stat button is located right here. It's beside the left-hand arrow. And if you're going to take statistics here at Valencia, you're going to be using this button a ton. So stat button, it's going to essentially be 2 steps once you get the hang of it. So step 1, we have to get the data we want to analyze into our calculator. So I'm going to hit the stat button, and I'm going to select edit, which is already highlighted every time for me, ready to go. So stat number 1, edit. So just hit enter right on edit. And you're going to have these lists, which they abbreviate with an L up here. So I have list 1 or L1, list 2, list 3. I'm only in this course going to use L1 or list 1. Now, if you already see some previous problems, numbers in there, you want to get rid of those numbers so you can type in your new questions numbers, your new questions data. It's easy enough to do. So to get rid of the old stuff under L1, I'm going to hit my up arrow key over and over again until L1 is highlighted. Now for me, I only had to hit it once. So I hit it once, L1 is highlighted, and to get rid of that stuff, I'm going to hit clear, which is located right below the down arrow. So clear, followed by enter. Now I'm ready to type in my new stuff. So again, let's pretend I'm just going to retype in some yucky stuff here. I'm just going to make up some numbers. So here we go. You hit the stat button, you selected edit, you want to get rid of your old numbers, so you hit the up arrow, highlight L1, hit clear, then followed by enter. Ta-da, it's gone. You're ready to go. Let's go ahead and type in our questions numbers. So we had 1.6, and then you just hit enter and just keep typing in all the data pieces. 3.8 was next, 5.0 or 5, then we had 2.7, 4.2 twice, 3.2, 4.7, 3.6 was next, and I just keep hitting enter. 2.5, 2.5. It's It's up to you. You might want to even just use your up arrow key just to make sure you've typed everything correctly under here. Make sure you have all the data pieces. Notice everything that repeats, I put it all the times it repeats even into that calculator under L1. So that was step one. I hit the stat button, I selected edit, which was option 1, and I just simply typed in every one of our data pieces under L1. Step 2, now we got to make the calculator compute the standard deviation for us. So I'm just going to hit the stat button again. And whenever we want the calculator to do stuff for us, in this course anyway, we're going to go over to calc for calculate. So I use my right arrow key. And we're only ever using option 1, just think in this course. Depending on which version calculator you have is how many times you're going to have to hit enter. So most of you probably have an 84 like I do. So I hit enter, and on this screen just keep hitting enter over and over again. So it says L1 is what you're going to use as the list. Enter, enter, enter. So I had to hit enter 4 times. Keep hitting enter until all of this comes onto your main screen. Standard deviation, what the question was asking us for, is capital S, X. Right here. It said round to the nearest hundredth. That's 2 digits out. So I look at the third digit. Because it's a 2, I'm going to round down. Keep it the same, in other words. So the standard deviation is approximately 1.05. By the way, in part A, you might remember we found the mean. The abbreviation for mean in statistics is X with a bar above it. So X bar, we said the mean average was 3.45 approximately. Yep, it sure is when we had the calculator do it. So if you wanted to find the mean, doing it this way instead of longhand, that's fine. Also, if I hit the down arrow several times until I can't go down any further, there's the median. They abbreviate it MED. We already found that in part B. It's 3.6. What's cool is we don't have to worry about reorganizing the data from smallest to greatest if we make the calculator find the median. We just type everything in. Q1, Q3, those are some of the quartiles we're going to be talking about later. But go back up here. Again, standard deviation 1.05. So just to summarize everything we did, step 1, we hit stat. We selected edit, we typed everything under L1. Step 2, we hit stat again. I go over to calc. I select one var stats, which stands for one variable statistics. I hit enter 4 times. You might only have to hit enter twice if you have a TI-83. Hit enter until all this stuff appears. SX, standard deviation, is about 1.05. If you have weird stuff going on in your calculator, or if, let's say, your screen when you go into edit, if you don't have an L1 here, one option at fixing it is you could reset the memory in your calculator. If you look, mem for memory is above the plus symbol. So if you wanted to do a hard reset, just as a heads up, if you use hard reset, if you have any games or formulas or programs stored in your calculator, they will be deleted. But a hard reset will do the job every time at getting all the original default settings back in there. So I have to hit second plus symbol for the memory menu to appear. I'm going to hit number 7 for reset. All RAM is a hard reset, so that will definitely get the job done. So number 1, all RAM, it's going to say, are you sure? Yes. Number 2 to reset it. It even warns you, it erases all the data in programs. So I know like a lot of people have games in their graphing calculators. It would erase the games. You'd have to re-download the games if you do this. But it will, if you hit the stat edit button, you'll see that everything will be blank and the L1 will be back in there. Going back to part F, standard deviation we said was about 1.05. I'll put the approximately wave there, 1.05. Final answer. Let's try one more. Let's say for example 2, it just wants the median and standard deviation of the following. I'm going to make the calculator do the work. I'm not going to do this longhand. You might want to jot down these numbers, hit pause on the video real quick before I switch over to my graphing calculator. Okay, so step 1, get the information in to the calculator. So that's stat, edit, get rid of the old data. So up arrow until L1 is highlighted, clear, then enter, gets rid of the old information. Now let's type in the new information. The data this time was 72, enter, 61, enter, 85, enter, 93, enter, 79, enter, 87, enter. So there, step 1 is completed. The data is into the calculator. Now step 2, make the calculator run the test to find standard deviation and median. Hit stat button again, go over to calc, select one there, stats, hit enter 4 times for those of you with a TI-84 plus on up. So 1, 2, 3, 4. Hit enter until this information comes into the screen. Standard deviation, if I round to the nearest hundredth again, remember that's SX. It's about 11.55 because the 4 as the third digit tells me to round down, so 11.55. If I hit the down arrow key over and over again, the median, abbreviated MED, which by the way is the same as the second quartile we'll see later in this video, is 82. So now I'm going to jot down those answers. So we said the standard deviation was approximately 11.55. And we said the median was equal to 82. I'll tell you what, let's go ahead and just do the median longhand for those of you that prefer doing it longhand. It's not too time consuming to do median longhand anyway. So if you wanted to see how to get the answer of 82 for the median longhand, step 1, got to rearrange your data from smallest to greatest. The smallest was 61. Next up was 72. Then 79. Then we have 85. Then 87. Then 93. Oh, let me make that 3 a little bit better. Step 2, we slash, cross out from each side. There's a tie between what lands on the middle. So for a tiebreaker round, you're going to do the mean average of the 2 remaining numbers. So there's 79 and 85, so I'm going to do 79 plus the 85. Divided by 2, this will give you the middle number, the halfway number. 79 plus the 85 is 164. Divide by 2, and we do indeed get 82, just like we did on the calculator. So honestly, it's your preference if you want to do median longhand or if you want to make the calculator do it. But 82, final answer. This section also discusses quartiles and percentiles. Example 3 says Kara Hopkins took an English achievement test to obtain college credit by exam for freshman English. Her score was at the 81st percentile. Explain what that means. So if she got the 81st percentile, that does not mean that she got 81% of the questions correct. It's not telling you the same information in that score as like a normal exam in a normal course would. A percentile score for any kind of a standardized test like this tells you approximately out of all the people that took that same exact test at that same exact time period, that's the score of the percent of people you outperformed, that you did better than. So if Kara scored at the 81st percentile, it means 2 things. The first thing is it means that Kara outperformed about 81% the 81st percentile, about 81% of all the students who took that same exact test. In this case, it was an English achievement test. Who took this English achievement test. If Kara did better than 81% of all the students who took that same exact test, that also implies that if I subtract from 100%, 100% minus her percentile, the 81st percentile, 100 minus 81 is 19%. So if Kara there did better than 81% of the students who took the test, that also implies that 19% of all the students who took that test did better than Kara. So approximately, I'll abbreviate approximately here, 19% of all the students who took the same test, this English achievement test, who took this test, outperformed Kara. So whenever you take a standardized test and in the mail, or if you do it on the computer maybe it tells you your percentile. It gives you two important pieces of information. It tells you approximately the percent of the population who took the test that you did better than, and it also can give you information about the percent of the population who did better than you. For the latter, you just subtract your percentile from 100%, just like we did here. The quartiles are a little bit different than percentiles. The percentiles divided up a number line into 100 equal parts is why they told us the percentage that you outperformed of the population. Quartiles, just like they sound because the prefix quart means 4, divide a number line into 4 equal parts. So looking at the number line I've drawn near the top of the screen, quartile 2, which is abbreviated with a Q and a subscript number of 2, is the halfway point on the number line. And I tried to estimate on here with my messy handwriting, I know, but where about the halfway point of that number line is. So quartile 2, you're actually finding the median, which we did earlier in this video. That's your halfway point. So if somebody scores at quartile 2 in a class, that means that they scored better than 50% of the population. So sure enough, they scored better than 50%. However, it also means that 50%, I'll do in blue, of the population scored better than them. But just think, because they might even give you some word problems with this, if you know that somebody scored at quartile 2, you should automatically associate that with as scoring better than 50% of whatever population you're studying. Then, if I look between quartile 2 and the smallest data value I have, which we call the minimum, I've abbreviated it min on here. If I do another median, another tick mark halfway between the minimum, the smallest value in quartile 2, that's quartile 1, or Q, capital letter Q with a subscript number of 1. And if somebody scored at quartile 1, that means they only scored better than 25% of the overall population. It also implies that 75%, because you do 100 minus that 25%, 75% of the population scored better than them. So you don't want to be told that you've scored at quartile 1 if you've only scored better than 25% of the population. So if there are any word problems in your homework that mention quartile 1, from here on out you should associate that with as having outperformed only 25% of the population. So Q1 is linked to 25%. If I did one more median, so quartiles are really just a lot of medians, between quartile 2 and the maximum data value, maximum of course meaning the largest data value you have. If I do another median, so the halfway point between quartile 2 and the maximum, that of course is going to give me quartile 3. Capital letter Q with a subscript number of 3. And if somebody scored at quartile 3, that number that's linked to quartile 3, the percent linked to it is 75%. So you've actually outperformed 75% of everyone that took that same test if you scored at quartile 3. It implies, though, that 25%, because you do 100 minus 75, 25% scored better than you. So from here on out, whenever you see Q3 or quartile 3, it's linked to 75%. It's honestly up to you when you hit the homework, when it asks you just to find each of the quartiles, if you want to do it longhand or if you want to make your calculator do the work. I'm going to go ahead and do it both ways. So looking at example 4, it says determine Q1, Q2, and Q3 of the following 50-point quiz scores. And here are the scores right here. So first, let's go ahead and make the calculator do it. Personally, I think the calculator is going to be quicker. So you want to go ahead and grab your graphing calculator. You might want to hit pause real quick on the video if you wanted to jot down these scores before I change over to the graphing calculator screen. The good news is that the way that we find the quartiles is not anything new. In fact, I've briefly mentioned that in a previous video. It's the same button clicks as when you found the standard deviation. So we're going to still be using the stat button. So I'm going to hit stat, enter on edit, stat edit to get my new data points into the calculator. Let's get rid of the old homework questions information. So I'm going to hit the up arrow key so that L1 for list 1 is highlighted. I'm going to hit the clear button followed by the enter button. So clear, enter, and ta-da, all that old information is gone. Now I'm going to type in the new information. So that was 44, 28, enter, 32, remember you're hitting enter after each one to get it into the calculator. 45 was next, 48, 37, 39, 46, 48, and finally 39, enter. Once all the data points are typed in there, and by the way, you'll notice I have some repeating data points like 39, that's okay. Type it in there both times if it repeats. You put every data point in there, even if it repeats tons of times. Put it in every single time into the calculator. So there's step 1. Step 2, to make the calculator figure out the quartiles for me, I hit stat button again, use the right arrow key, go over to calculate, and you're going to select option 1, 1var stats, which stands for 1 variable statistics. On the TI-84 plus, I'm going to hit enter 4 times, so I just keep hitting enter 1, 2, 3, 4 through the next screen. I believe if you have a TI-83, you only have to hit enter twice. Pretty much just keep hitting enter until all of this information comes onto your main screen. If your information like this does not come onto the main screen, you might want to reset your memory, as I've showed you in a previous video. That's second plus sign, option 7 to reset all the RAM. That'll do a hard reset, and then you should be able to use the features to get to this screen. There's the standard deviation, but we wanted the quartiles, so you got to hit your down arrow key. Keep hitting down until you cannot go down any further, and there we go. So quartile 1, which is abbreviated as Q1, is 37. Quartile 2 is abbreviated as med because it's just the overall median of the data. So quartile 2, aka the median of everything, is 41.5, and quartile 3, which is Q3, is 46. If you are going to take statistics, you're going to be using the quartile numbers a bunch, and you're also going to use the min and the max to make something called a box plot. But for now, just do Q1, Q2, and Q3. I'm going to go ahead and jot that down as the final answer on my main screen. So jotting that down, we said Q1, Q subscript 1 for quartile 1 equals 37. Quartile 2, Q with a subscript number 2, was 41.5. And quartile 3, Q with a subscript 3, was 46. So that's one way that you could get the correct answer of the quartiles whenever the homework and even the test asks you for those. The other way, if you prefer to do it longhand, that's fine. Remember, quartiles, you're really just finding medians over and over again, and we already know how to do that longhand. So step 1, I'm actually going to find Q2, the main quartile, because it's the overall median first. And before I can find a median longhand, I got to first rearrange all my data points from small to large. That was nice about if you're using the graphing calculator, is I didn't have to rearrange them from small to large. I just typed them all in and I made the calculator do the work. But if you are doing it longhand, we do have to rearrange them from small to big first. So it looks like as I skim my data points, 32 is the smallest. Oh, no, sorry, 28 is even smaller, which is beside it. So 28, comma, then 32. I see a 37, comma. I see two 39s, so 39, comma, 39, write them both. Then it looks like 44 is next. 45 after that. 46 after that. And finally 2 48s. And I just counted to make sure I have all 10 scores there, and I do. So now step 2. We said we're actually going to find these quartiles out of order. You're going to find quartile 2 first. That's the median of all the data. So I just slash 1 from each side. Remember, median means the middle number. So goodbye, 28 and 48 cancel each other out, and just keep slashing 1 from each side. And there is a tie between 39 and 44. So to do a tiebreaker, we do the mean average. So I'm going to do 39 plus the 44, and then I'll divide by 2. So if I do 39 plus 44 first, that gives me 83. Divide 83 by 2, and I get 41.5. Yay, so I have my first quartile doing it longhand. And you can see we got the same answer on the calculator. 41.5 is quartile 2. I'm going to need to erase. Remember, when there's that tie and you're looking for a median, do the mean average between the two numbers. Add them up, divide by 2, and that will give you that answer. So quartile 2 is 41.5. And just imagine a little divider. I'll do an all messy divider right here where I'm scribbling. There's where 41.5 is. So that's going to divide your data in half, is why I'm saying imagine a divider. So there's a divider between the smaller numbers, which we call the lower half of the data. Everything's smaller than quartile 2. And the upper half of the numbers. So the divider, quartile 2, that divider number divides your data into lower half and upper half. Everything bigger than quartile 2 is the upper half. So if I want to find step 3, quartile 1, I'm going to do the median of just the lower half of the data. So I go back and I slash, I'm going to slash in blue this time, just the numbers smaller than quartile 2. So everything smaller than 41.5, hence why I drew this weird divider right here. So everything that comes before that divider starts slashing from each side. So goodbye 28 and 39, goodbye 32 and 39. So the middle number, the median of the lower half of the data is, I land on 37. And I got that same answer on the calculator. I'm going to rewrite this a little bit nicer. So quartile 2 is still 41.5. Quartile 1 is 37. And finally, step 4, the only quartile left is quartile 3. To find quartile 3, you guessed it, we're going to do the median again, but now of just the upper half of the data, so everything larger than quartile 2. So here was my divider, my scribbled divider, where 41.5 quartile 2 lands. So now start slashing everything to the right of that, everything larger than that. So that means goodbye 44 and 48. 45 knocks out 48. And the middle number there is 46. And that's what we got on the calculator as well. So you can see doing it longhand, you're going to get them out of order because you'll do quartile 2 first. But we got the same exact 3 answers. You just do medians over and over again. Quartile 1, 37. Quartile 2, 41.5. Quartile 3, 46.